Hi, everyone. Does that work? Yes. Very well. Thank you very much for joining us, for you here and the ones that are following from online. So this is us. My name is Simone Sciarrati. I'm a developer platform lead at Recorded Future. But before that, I've been working more than 8 years at Meltwater and a long time at pleasure to work with Federico Hernandez at Meltwater, where he's a principal engineer.
Morning, as we have learned.
We're both based in Gothenburg, Sweden. A word about our companies. Recorded Future is the world's largest intelligence company, and our mission is to secure our world with intelligence. If you want to know more about that, you can go to www.recordedfuture.com. And with regards to Meltwater, it is a software as a service company as well, and its mission is to help customers better understand, influence, and engage with their key stakeholders in the media intelligence area. You can see the services that are provided, and you can go to meltwater.com to find more information about it. Very well. Now, to give some context, in terms of the engineering organization at Meltwater, it's a global company. We had offices all over the place. The engineering force is about 300 people, and we're organized in about 40 to 50 teams. All these teams are autonomous. They can choose the technology they want. And what we're doing together at Meltwater is building a platform that could help the engineers go through the build, testing, deploying, monitoring, and remediation. So an internal platform. And one important thing is that all the teams are autonomous. They can choose to use our services or not. So we have to do a good job so that they can stay with us. Kubernetes is one of the things that we provide at Meltwater as a platform. We provide that to 40 teams. We have more than 10,000 pods on the larger cluster, 3,000 deployments, lots of resources, and we provide different instance types that are targeted to specific workloads, memory intensive, CPU intensive, and GPUs. I will slow down now. You can see here, this is a screenshot of our larger clusters. You can spot in the top right the instance types, GPU, and different kinds. This is what it looks at a glance. So Kubernetes is just one part of the story. Of course, that in itself helps, but it's not a complete story. It doesn't help engineers throughout their journey. So we have a lot of components that are installed in that, and you're probably familiar with that. KIDA for auto-scaling, observability, and integration with CI/CD. One important part for this presentation is that we are an AWS shop. And we started this project to use Kubernetes in 2018. And at that time, there was no EKS or any other managed service. So we adopted KOPS, which is a project within the Kubernetes project organization. And KOPS is a tool that allows you to either define programmatically the Kubernetes cluster in YAML, and then realize that, or as a command line, you can just pass arguments, and it will go and do its job and create a cluster. With regards to the CNI, when we started, we wanted to have native routing, and the only choice at that time was the AWS VPC CNI plugin, which is what we used. So we're talking, this is something we did, this talk is about a project that we ran in 2022. So we've been running 4 years with the CNI that we started with, and it was working okay, apart from some issues. What was the main driver to actually to change this? Why did we want to use something else? The practical new requirement was to have encryption between the nodes, of the traffic between the nodes. But in general, we had been keeping an eye on what was going on in this space, and in particular with Cilium, with all the functionalities that it would provide. For example, network policies. This is functionalities that are not present per se in the AWS CNI plugin. It does one job and it just does it well, but it doesn't really have, it's not a full-featured CNI plugin. And also Cilium provided on top of that a lot more better visibility about what was going on in the networking in the cluster. So we decided that after looking at all the other options, we decided that Cilium seemed to be the one that had the longest legs. Also because at that time, Google announced that it was going to be the default for GKE. DigitalOcean also adopted it, and even AWS for EKS Anywhere. So it looked like we probably were not making the worst decision. So when we got to it, what were our requirements? In our environment, what was that we had to do? And we obviously wanted to have it seamless, so we had to carry out this migration without our users noticing. That is always the goal. So no disruption to workloads, nothing more than normal deployment or a node being retired. And we didn't really have the tooling at the time, or actually to do create a new cluster and then move everyone there. So it had to be done in the same cluster. The cluster would evolve, but in the end it would be the same cluster at the end. And we didn't want to have to change tools. We liked COPS, how it was working for us, and we wanted absolutely to keep native routing because that makes it easier to think about networking. We didn't want any of the components that we had running, like all the integrations with observability, CI/CD, autoscaling, all of that had to continue working during the migration and after the migration. And of course, we didn't want to have to upgrade Kubernetes as a dependency for moving to Cilium. So if we were starting to learn Cilium today, we would go here. There's a lot of good labs that Isovalent provides. But at that time, we didn't have that. So we started from that, which is documentation, which is really good. But there's a ton of documentation and a lot of options. But also the way we started was very simple. We didn't try to define the cluster, use all of the features in defining in the YAML file for COPS. We started very simply to just create a cluster and just make it use Cilium. And then we observed, in the cluster, what were the differences in the main components, like the kubelet configuration, the API controller configuration, the kubeproxy. And after exploring a bit of the possibilities of COPS in terms of managing Cilium, we decided that we wanted to have a bit more control and flexibility, and we wanted COPS to not manage the CNI at all. We wanted to manage Cilium on its own using the Helm charts that are provided by Isovalent. So what we want is something like this, basically. Don't care about the CNI plugin, we will take care of it ourselves. And this, when we did something like, when we used that option, we saw that COPS was actually adding a flag to kubeproxy that we didn't want. Suddenly it came up, and it was like making a decision on what we wanted to pass to kubeproxy that was not, we didn't want to have. So the first step was to actually reach out to the COPS community and provide a PR to change that behavior, which was hopefully was merged, so we didn't have to run with a fork of COPS that like we've done a few times. And after we had this good way to create a cluster, what we wanted to check is that the performance of this new CNI wasn't worse than what we had before. That's also obviously an important part of it. And again, we refer to very good documentation on the Cilium blog. That also they look, apart from explaining the testing that they did, they also refer to the tooling that you can use. So we built a cluster more or less the same size of what we had in production with artificial load, and we run performance tests. And in the end, we saw that we weren't really losing a lot of performance compared to what we had before, with and without encryption. So we were good to go with it. So I will hand over now to Federico.
Yes. So we knew that Cilium was working and we were good enough. And now was the question of how do we migrate from the AWS CNI to Cilium without bringing up new clusters and have all the teams migrate. We wanted to do this migration in place to not disrupt application and workloads. Remember that we had 3,000 applications running in the clusters. So we came across a blog post where JetStack was basically doing, and Skybet doing the kind of like the same live migration inside the cluster from Flannel to Cilium. And we looked at this approach and got inspired by it, and we thought that by using the AWS CNI as a starting point, it would even be easier to migrate to Cilium to it. And we'll go through the steps in a short while. Because of all the workloads we needed to migrate, so think about them, they were running on nodes with AWS CNI, and then they needed to run on nodes with Cilium CNI to keep connectivity. And just through the huge amount of pods and deployments, we knew already also from our previous upgrades that this will take some time. Probably more than one day to migrate everything. And we also wanted to ensure that this can be done through multiple days without having to work the night. So we wanted to start the migration in the morning after have some coffee, migrate nodes, migrate applications, and then call it a day in the afternoon, and then start the next day, and then continues until the clusters, everything was migrated to Cilium. So we knew that during the night times, we need to live with both CNI plugins. And the process was basically like this. We had the cluster, the nodes, the control plane running with the AWS CNI, and we basically just marked it. These are nodes with running AWS CNI. And then we brought up Cilium in a configuration where we told Cilium, don't run on nodes that are using the AWS CNI. And then we replaced the control plane one by one, and then the control plane was using the Cilium CNI. And since we're using native routing, all the pods that were running on the control plane would still communicate with the rest of the cluster. And then we just continued. We brought up new nodes, and with the configuration of Cilium to only limit it on nodes that are not using AWS CNI. And we also configured AWS CNI to not run on newer nodes where you should not run. We could bring up nodes with Cilium CNI, and we had the old nodes with AWS CNI at the same time, and then we just cordoned and drained the old nodes, and the applications just migrated over to the new nodes. And then once that was done, we could just let the cluster autoscaler do its jobs and terminate the unused nodes. And once we're happy with this procedure, we wanted to automate this and codify this procedure. We tested it a couple of times in test clusters, and we told teams, we're going now to migrate your applications from the old nodes to new nodes. You will see pod restarts. We didn't do this right away in the production clusters where the Meltwater applications are running. We have a couple of internal clusters that the platform team uses for observability, to run the observability platform internally. And so we tested this migration procedure there, and without affecting external applications to be affected, only internal applications. And this worked, almost. we found an issue that we didn't see during testing, where pods being allocated on secondary network cards could not communicate to the world. And this is because Amazon drops packets if they're not configured correctly. So we found an option that we needed to turn on in Cilium. And that's nice to dogfood a new configuration and a new component in some kind of production cluster, which is not real production for your customer-facing applications. Because during testing, and we tested this for weeks and months, we didn't discover this issue. Yeah, and once we were happy, we then did the real migration with the steps that I presented to you earlier, where we brought up new nodes with Cilium and then moved the pods around. And even there, we discovered a few things during the migration. The daemon sets for the Cilium CNI plugin uses a little bit more of resources on the nodes. And a couple of our teams, they were requesting too much for their pods on the nodes, so they couldn't start. We needed to talk to the team. They adjusted their resource requests, and then everything was fine. We also discovered that we missed instances with lower IP limits, and Cilium would not start up on these nodes. These were GPU nodes, the smallest ones, and we worked around with that to bring up a little bit larger nodes and work with the teams to run their GPU applications, multiple GPU applications on those larger nodes. And we overcome that problem with lower IP limits. Before we even started the migration, we needed to reconfigure the kubelet also live in the cluster to overcome an issue with the kubelet at that time of that Kubernetes version to get a new addressing scheme. But that worked as well quite nicely. And we migrated the cluster. It took a couple of days. And I think 3 days. We started on a Tuesday, and then on Thursday everything was fine. And then we went on for the weekend.
To celebrate. And specifically, we went on holiday 1 week. Or maybe so we believed, but it didn't really work out as we thought it worked out. So on Monday morning, we started getting, or whatever, our colleagues that were in the office, they started getting a lot of reports of errors happening in the cluster. And the vast majority was reporting DNS issues. And of course, it's always DNS, so it must be DNS. So we looked into core DNS. We looked at if queries, if we had like more queries, if we were reaching some kind of limit. We increased the number of replicas. We changed the cache settings, and we enabled debug logging, which is extremely verbose. But that really wasn't the issue. So it is not DNS. So we talked also to the AWS Enterprise support, since we have it. Then we looked at maybe it could be limits. There is a limit on the number of packets that you can send to the VPC resolver from an CNI interface. Maybe we were reaching that, and that would be sort of invisible because it just dropped. So that's what we would see, that at some point we couldn't make queries. But after hours debugging with AWS support, it turned out that it wasn't that. Some of these limits you can't really find good metrics, not even in CloudWatch. So it's kind of a bit hidden. And then we looked at the network performance metrics and its limits on the ENIs. Again, we went down the rabbit hole of installing all the exporters to get all the metrics and talked to AWS, but it wasn't that either. Maybe it's Cilium. Could it be Cilium? Of course, in the end, it turned out that was something related to Cilium. We found out that after a restart of the agent on the nodes would fix the issues that we had seen in the pods. But again, now we had a very, very difficult question to answer. What do we do? Do we roll back to the AWS CNI, and we potentially lose any way to troubleshoot this, because despite all the testing that we had done running the Cilium in the same configuration in the other production cluster, we had never seen this kind of behavior. And this started happening 4 or 5 days after the release was completed and more than a week after it was started. So this was also a business question. What is the impact on the business? And luckily, it turned out that the cluster and the applications were resilient enough that the impact on the business wasn't that much. So we went down and we decided to keep it running so that we could collect as much information as we could to troubleshoot what was actually happening. Alongside this, when we had to keep the communication open. Obviously, we had video call open for everyone to join while we were troubleshooting and making decisions and to help us. And also, for example, Slack threads said we could continuously update what was going on. Made this decision, then we started with debugging what was actually happening.
Yes, and the debugging took a couple of weeks to find the issue, and we tried to reproduce this in other clusters, but in the end, we only saw it in the production clusters. And the fact is, this happened because in the production clusters, due to the sheer amount of pods and auto-scaling and deployments happening, new versions being deployed to the cluster, there was a constant reuse of IP addresses, pods going away and new pods coming. And when this is going on at a certain scale, the IPs are reused, and then we found that there was a mismatch in the routing that is happening for the CIDRs in the native IP addressing of the network space that we were using for the cluster. So pods were getting IP addresses that had different routes set up. And in the end, we found out that there was a small bug in Cilium, which we then, with the help of the Cilium project, could provide a PR with. They helped us a lot to make this go into the Cilium version. So it was then merged after a couple of weeks. And this was when we were still using the 1.10.15 version. So with this, then the problem disappeared. Another thing is that to discover this bug, we also turned off encryption, which was the initial reason why we wanted to switch over to Cilium. And in the meantime, being at another conference, we also learned about that actually AWS supports now native encryption on their network cards. So we never turned back on encryption in Cilium. And that enabled us then as well to go and use another functionality inside Cilium, which is exclusive. If you have Cilium, if you have encryption enabled in Cilium, you cannot run without the kubeproxyless configuration in Cilium. So either you use encryption or you run kubeproxyless. And we wanted to go kubeproxyless in the end, since we're starting to see performance issues with the kubeproxy and the programming of IP tables. It was starting to take minutes to reprogram IP tables with kubeproxy. And those issues went away once we configured Cilium to run kubeproxyless. Another feature that we're now investigating with Cilium is to overcome these in-place upgrades and use blue-green cluster deployments. You have your cluster running, your production cluster. You bring up a new cluster, and with the help of Cilium and the cluster mesh and some Route 53 external DNS magic, you could transparently migrate the applications from one cluster to the other. And this seems quite promising. This migration from AWS to Cilium, we partnered them with, since there was this blog post out for Flannel to Cilium, and there was nothing for AWS to Cilium. We partnered with Cilium and the CNCF and wrote a case study and blog post about it. And this is getting traction, these live migrations from one CNI into Cilium. Cilium implemented a CRD for this as well to help you in the process of labeling old nodes with the old CNI and the new nodes to the new CNI. And there's even demos happening. This is from last week, live migration on an AWS EKS cluster to Cilium. And with that, thank you. If you have any questions, does the app work or is it shouting?
Really well done. It's so cool to see exciting technology such as Cilium being used out there at scale. We did receive one question on Slido, but we can also take questions here in the audience, the old-fashioned way, where I get to choose who asks the question. So the question we received in Slido was, how close to the real world were the applications you tested the CNI migration in your test clusters with? Any lessons there?
Yeah, I mean, at least one. We did not test on GPU instances because they were expensive. Don't be cheap, because we just found that problem during the production rollout. It's a good question. The applications were, we were more testing for network connectivity, so we were just a bunch of normal HTTP servers, and we were load testing from the outside and from the inside, but it wasn't actually, I think, as close to reality as it was. But we were focusing on the connectivity, basically.
Yeah, and for that we set up, launched in the test clusters hundreds of ingress controllers and hundreds of deployments with services behind these ingress controllers, and then we were load testing them from the outside and from the inside of the cluster to simulate the network traffic. Yeah. But again, we could have done larger clusters in the same way as the production clusters. And as Simone just said, don't be cheap. It costs, but it's probably worth the money, and you get less of a headache in the end.
And you can have your week holiday.
Yes, exactly.
That's a lesson for life. Don't be cheap. We received one more question. Did you take a look into Cilium's ingress controller yet?
No. When we started with Cilium, that was not a thing yet. But once we do these, so we migrated to Cilium, and then we went the kubeproxyless route, and now we're looking into these blue-green cluster migrations, and this will probably be looked at later on because it's very interesting to reduce the mess of ingress controllers out there. We'll see. There's so many things in Cilium to use and test.
I'm going to sneak in one last question. If I only want to use the service mesh for the pod-to-pod network encryption, and I am already using EKS, can I use the native AWS VPC CNI encryption instead?
Is there a native VPC CNI encryption? Is that like the node by what we mentioned? As what we mentioned in the slide is basically the traffic between the nodes is encrypted automatically by AWS. I think you can also use Cilium on top. What is it called? Chained.
Yep.
With the AWS VPC CNI, so you can keep the CNI and have chain Cilium. I'm not entirely sure if Service Mesh would work with that. But also, I think there is a way to not use the VPC CNI in EKS and replace it with Cilium, if I remember correctly.
Yeah, you can remove it. You can also run in chain mode.
Yeah.
I like the last question, and then we conclude.
Yeah.
Yes. Bash script, yes. We had Bash scripts for cluster upgrades, so we just did the same migration there. It works. It's easy to understand, and it just works.
Wonderful. Give one more round of applause to Simone and Federico, please.
Thank you.